All right, hey everyone, it's Hutch here, and we are still in Module 1, but Lesson 5. So your I can statement says I can write equations to represent proportional relationships, and from that also identify the constant of proportionality, or the COP, in the equation that is a proportional relationship. Okay, so let's break down what that means. Basically, every proportional relationship can be graphed, and you can represent that proportional situation with a specific formula. Okay, and that specific formula looks like that, where you have y equals, and then whatever the COP is, times x. Okay, and so here it is in words. A linear relationship is proportional when the ratio of y to x is a constant k. So basically, when you take x and multiply it by the COP, the constant proportionality, it equals y. Okay, so let's go ahead and take a look at some examples to build some context to this situation. Okay, so follow along with me, write exactly what I'm writing. Example 1, can you identify the constant of proportionality in equations? So it says Olivia bought 6 containers of yogurt for $7.68. What they did was they found the unit rate of that, okay, which would be cost per container. So to break down where they got this y equals 1.28, what they did was they did the $7, because we know money goes on top when we're doing unit cost, and 68 cents over the 6 containers, and made a unit rate for one container. How much was the cost? And so we know to do that, we do 768 divided by 6. So I just want you to see where they got that number, and you can see it equals $1.28 per container. Okay, so this is the unit rate. I'm going to highlight this, and now you can see where they got the number that created this equation. So the equation is when you take an x, okay, and multiply it by 1.28, you'll get what y is. And we know that's what constant of proportionality means. Okay, so when you see an equation like that, and it's in the form of y equals constant of proportionality times x, you just know the COP is right there in that spot. Okay, so what is the COP? So we can say COP equals 1.28. And it says explain what it represents. It represents the number we multiply by. I should say multiply x by, and here's how you can write an x so it shows as a variable like that, by, to get y. Okay, so it represents the number we multiply x by to get a y, okay, in any proportional situation. So let's go ahead and explore this a little further so you understand why we get that equation, and also where we get this y over x. So we'll have this make sense a little bit more. It says you can use the constant of proportionality or unit rate to write an equation in the form of y equals k times x. Okay, so that's the equation that represents a proportional relationship. So I do want to say to you, if you ever see like k times x plus 1, instantly that's not a proportional relationship. This is the only equation template that needs to be existing to have a linear proportional relationship like we saw in the graph up above. Okay, so how can we find k? You can find k by writing the ratio comparing y to x. So to write the ratio, solving the equation y equals kx for k. So let's see what we would do. So first is write the equation. So right here, let's write y equals k times x. Okay. We want to go ahead and solve for k. So let's see what that looks like. Okay, so I'm going to divide each side by x. Divide by x, divide by x. Okay, so that cancels that out. And what you see left over is that y over x equals the constant of proportionality. Okay, and so that's where we get that original y over x that we were using in our other lesson as well. Okay, so the constant of proportionality is the ratio y over x, but notice x can never be 0. Okay, all right, example 2, proportional relationships and equations. So a little bit more context here. JC bought 8 gallons of gas for $31.12. It says write an equation relating to total cost y to the total number of gallons of gas x. So they're letting you know cost is y, gallons of gas is x, and they are letting you know it's a proportional relationship. Okay, so first of all, to make that equation, I have to have the unit rate, because we know unit rates are what tell us the constant of proportionality. So let's go and record down our original ratio, and we always do the cost on top. Okay, so we have $31.12 over 8 gallons. Okay, and we want to make a unit rate. Okay, so how do we find unit rates? Numerator divided by the denominator. That goes on top, and it's always going to be over 1 gallon. Okay, so let's grab our calculator. Make sure you clear all. $31.12 divided by 8 gallons, and we get $3.89 per gallon. So this is our COP, okay, that we can now use to make our equation. Okay, because remember the variable for these equations, the COP is going to be K. So we have y equals K times X. Okay, that's the equation for the graph. So the constant of proportionality is 389. Okay, write the equation. The equation is y equals K times X. Okay, now plug in the COP to this, and we would have y equals 3.89 times x. What does that mean? That means any x we have, if we multiply by 3.89, it'll tell us what the y is. Okay. All right, let's go down to example 3. Jack is in charge of a 120,000-gallon swimming pool. Each spring, he drains the pool. When finished, he refills it with fresh water. Jack can fill the pool with 500 gallons of water in 5 minutes. So I just identified our original ratio, and it says write an equation that represents the relationship between the number of gallons, y, and the number of minutes spent filling, which is x. Okay, so to show the proportional relationship as an equation, I need to first find the unit rate. Okay, so it's gallons of water in 5 minutes. And they're saying gallons of water is y and number of minutes is x. So let's go ahead and find the unit rate of that. So we have gallons per minute. Okay, so we have 500 gallons for 5 minutes. And let's go ahead, we're going to make a unit rate, so that's over 1 minute. And 500 divided by 5 equals 100 gallons per minute. Okay, so if we know now that Jack has 120,000 gallons to fill the pool. We can now figure out how long it will take him. Okay, so let's go ahead and create our equation. So we could create a proportion to solve this, which we're a little bit familiar with, or we could use this equation to solve it. So since we're talking about equations today, let's go ahead and do that. Okay, so y is the number of gallons. Okay, and so in this case, we have number of gallons is y, number of minutes spent filling the pool is x, and so we have this proportion of 100 gallons per 1 minute equals, and we want to know what if we have 120,000 gallons. How many minutes would that be? Okay, so you could find the multiplier for this, or you could do means extremes or cross multiply. Another option, though, is since we know what the unit rate is, this is our COP, is the 100 gallons. Okay, and so we have y equals 100 times x. Okay, and so your other option using the equation then would be to just plug in the information that you want. Okay, and so if we know that there's 120,000 gallons, okay, look, number of gallons is y, okay, and number of minutes is x, so I could go ahead and put 120,000 in for y, for number of gallons, equals 100x, and then I just have to solve for x. So how do I get x by itself? Divide 100 both sides, which cancels out my hundreds, and you have 120,000 divided by 100, and we're going to move that decimal place, and we have 1,200 equals x. Okay, and so this, and because x is minutes, is 1,200 minutes. Okay, let's see our cross multiplying over here in our equation. So you have a couple options. We could do the cross multiplying, which also gets you 100x equals 120,000. Okay, and you can see how that's the same thing we got over here. Okay, just another way of getting that answer. Okay, your other option would be find the multiplier, which is asking 100 times what gets me 120,000, and you could figure that as well. So lots of ways to accomplish the same task. But either way, we have 1,200 minutes to fill that pool. Okay, and if you wanted to divide by 60, you could find out how many hours that would be. All right, let's go ahead and take a look at the apply. It says Hugo can run 4 miles in 25 minutes. How many more miles can Hugo run in 90 minutes than in that original 25? So here's my original ratio, okay? And then I want to change it. It's asking me, well, what about 90 minutes? And then it does say how many more, so they want to know the difference in time of those two things. So that's our apply part. It has an extra step there. So let's start by writing our original ratio, okay? Let's see, do you want to go miles per minute or minutes per mile? You should probably do miles per minute because that's the order that exists there. So we have 4 miles per 25 minutes. Okay, and let's go ahead and figure out what the unit rate is for this. Okay, or you could just put in what you want to find. So I want it to be 90 minutes, so I can actually figure out what the multiplier is for this to find out how many miles. Okay. So if I look at my 25 to 90, I'm asking, well, times what over what? So 25 times what gets me 90? So I can just do my inverse operation, 90 divided by 25. And so you can see our multiplier is 3.6 over 3.6. Okay, and so 4 times 3.6 is 14.4 miles. Okay, so there's my amount in 90 minutes. And then I have my amount in 25 minutes. It does say how many more miles can Hugo run. So I'm just going to show my work here. Minus 4 miles, 4.0. And we have a difference of 10.4 miles. Okay, so that's how many more miles Hugo can run in 90 minutes. Okay, and there you go. I am going to show you the other option, which would have been to find that unit rate and make the equation. Okay, so if I want to find the unit rate for this, we know that we just take the numerator divided by the denominator. Okay, so 4 divided by 25, and I would get a unit rate of 0.16 miles per 1 minute. And since I know that unit rate, that's the COP, and I can make my equation. Y equals K times X, or Y equals 0.16 times X. And now I can use this equation to answer any questions I need. Okay, and so if my equation here is y over x, okay, all I have to do is plug in what I want. So I want to know minutes, okay, and so minutes is x, so all I have to do is put in my information. So y equals 0.16 times 90 minutes, and when I do that, 90 times 0.16, and you can see we also get 14.4 miles. Okay, and then we would still subtract and get our final answer. So you have two ways of doing that, and you're going to find what's most comfortable for you. Okay, all right, let's go ahead and take a look at the homework problems. Okay, so these are in-class practice that we would be doing, and then you'll see what's your responsibility for homework. So some of these are going to go pretty quick now that I've spent a little extra time teaching you some options. So Liv earns $9.50 for every 2 bracelets she sells. Here's the equation, and there's the unit rate, or the COP in this case. So they already figured it out for you. Okay, and so they're asking, what is the constant of proportionality? Well, that's easy. You know that the COP is this spot right here in the equation. So we can just right away say the COP is 4.75. It says, what does the constant proportionality represent? We need to say it represents the number you multiply any x by to get y. Okay, so that's what that means. It also means that if I have 1 of the x, if I multiply 4.75, it'll tell me what my unit rate is. Okay. All right, so you're going to do number 2 on your own. It's the same idea as number 1, so you can imitate that. Let's take a look at number 3. Lincoln brought 3 bottles of an energy drink for $4.50. Write an equation. So now they're not giving us the equation like they did here. So to get the equation, I need to find the unit rate. Okay. And so bought 3 bottles of an energy drink for $4.50. Okay. We have cost is the y, and energy drinks is the x. And so remember, the equation is y over x, okay, for us to plug this in. So that's $4.50 for 3 bottles of energy drink. Okay, so we want price per bottle. So how do we find unit rates? Same thing every time. 1 bottle's on the bottom, numerator divided by the denominator. So $4.50 divided by 3 is $1.50 per bottle. So we know this number here in our unit rate is our COP, our constant proportionality, and now we can plug it into our equation. Because remember, the equation for a proportion is y, a proportional equation is y equals k times x. Okay, so let's go ahead and write the equation. So that equation is y equals 150 times x. And what does that mean? It means any x that we have, okay, any number of energy drinks is x, okay? If we multiply it by 150, it'll tell us the cost, or y, okay? All right, so number 4 is on your own. It's the same as number 3. All right, let's take a look at number 5. Marley used 7 cups of water to make 4 loaves of bread. So there's my unit rate, or my ratio. What equation can be used to model the total cups of water needed? So water is y, and x is the loaves, okay? And then how many cups of water do you need for 6 loaves of French bread? So it's sort of like that apply, where we're applying the next step to that as well, either through a proportion or plugging it into the equation. So first of all, since we have to make an equation, we need to know what the unit rate is to find the constant of proportionality every single time, okay? So let's look at what x needs to be and what y is. We know we're finding the unit rate in this order, y over x. So x is water is y and x is loaves. So that's 7 cups of water. Here, let's do cups of water. And the loaves is x, and loaves is 4 loaves. I'll just do L here, okay? So let's create our unit rate and find out how much for 1 loaf, okay? And so how do you find unit rates? We know we take our numerator divided by our denominator every single time, and it's 1.75 cups of water, okay? All right, so there's my unit rate, which is also my COP. Okay, so let's create our equation. I'm writing the whole template first. Y equals k times x. And let's go ahead and plug it in now. So y equals our constant of proportionality times x. Okay, so there's our equation. So we took care of that. What equation can be used? That's step 1. Okay, how many cups of water to make 6 loaves? So is loaves x or is loaves y? Okay, right here, look, x loaves. So all we have to do is plug it in to the x. And so that's the tricky part, is paying attention. Does it go into y or does it go into x? So 1.75 times the 6 loaves, and it'll tell us how many cups of water, or y. Okay, so let's go ahead and solve that out. So you can see that's a lot quicker than making a whole proportion, is just using that proportional equation. 1.76 times 6, and it equals 10.56. And then think about your label. Okay, that's cups of water. Okay. And so there we go. That's what y is 10.56. So we have y equals, okay? And there we go, okay? All right, you are going to do number 6, which is the same template and idea as number 5. All right, number 7 here. In your homework, it says the table shows the cost of 4 movie tickets at 2 theaters. select the statements that are true about the situation. Okay, so this is the cost of 4 movie tickets. Okay, so 4 tickets cost this much. So I'm making some notes here. 4 tickets cost this much. Okay, so let's go ahead and take a look and find some things that are true. So they're saying the equation is y equals k times x, and that models the cost for tickets at Star Cinema. So we're just wondering, is this the unit rate? Is that the COP for Star Cinema? So let's just check. So $31 per 4 tickets, and let's see if that is the unit rate for 1 ticket. So we need to do our division. $31 divided by 4 tickets, and it says 7.75. $7.75. So is that true? If that went in there for the COP, yep, that's a good one. So check. All right, they're saying the equation y equals 30x models the cost for Movie Galore. So go ahead and do the same thing and check the unit rate for Movie Galore. So we're doing $30 for 4 tickets, and see if that unit rate ends up being 30. Is that even possible? I don't think so. Okay, so we already know that's not going to work. All right, the total cost for 9 tickets at Star Cinema would cost $69.75. So let's go ahead and finish out creating the correct equation for Star Cinema. Okay, so 30 divided by 4. So it's actually $7.50 per ticket at Star Cinema. So if that's per ticket, okay, what would 9 tickets at Star Cinema cost? So remember, this is y over x. So we could create the equation, right? Y equals 750 times x. That's the linear equation. Okay, that's the proportional equation. And we can plug in any amount of tickets. So tickets are x, money is y. Okay, so we're asking, well, what about 9 tickets? Okay, well, tickets are x, so that's 750 times 9. 750 times 9, $67.50. $67.50. Nope, that doesn't work. All right, and the total cost for 1 ticket at Movie Galore is $30. Is that true for Movie Galore for 1 ticket? We already know that's not true. Okay, it was $30 for 4 tickets. Okay, so it only ends up being the first one being true. All right, the last bit here, I'm going to do number 8. Your responsibility will be number 9, which is pretty similar. Okay, and then I want you to just explore number 10 on your own and see what you can do with that. We've already done different graphs and things like that. I want to see if you can put all that information together and figure out what to do with number 10 on your own. So let's finish off with number 8 together here. Roman can type 3 pages in 60 minutes. There's a ratio for you. How many more pages can he type in 90 minutes, okay, than that original? So this is very similar to our how much more that we did. Where was that? In our notes, actually. Okay, let's go ahead and set this up. We have pages per minute. Okay, sounds like a pretty typical rate. So let's do 3 pages in 60 minutes. And let's figure out what the unit rate of that is per minute. Okay, so 3 divided by 60, okay, is 0.05 pages per minute. Okay, and remember, what is this top part? Well, this top part is our COP, just like always. Okay, it also allows us to then fill in the equation. So y equals k times x is our equation, and let's go ahead and put the COP in for k. So we have y equals 0.05 times x. And that means any x times 0.05 will tell you y. Okay? And when we set up our ratio, the top is y and the bottom is x. Okay, so let's go ahead and plug in what we want. Okay, so I'm looking up here. I want to know how many more 90 minutes instead. So let's go ahead and plug that into the equation. Okay, minutes is x. Okay, it says right here, minutes is x. So we have y equals 0.05, and let's plug in the 90 minutes instead. Okay, and let's have it tell us what y is. So y equals how much? So 90 minutes times the constant of proportionality, it'll tell us y, and y equals 4.5. And what is y? You have to look up at your label. That means pages. And there we go. That's how we can use the equation to solve the problem. All right, the rest is on your own. Let me know if you need help with that. And then if you're absent, then you can show me your completed work, or you can even email me a picture of it when you're done.